Hello everyone. Today we'll be going through ES A-level chemistry and the topic is accurate relative atomic masses, and this is subtopic from the main topic, which is atoms, molecules and stoichiometry. To cover this main topic you need to go through these 8 videos which are there in the playlist, and this will be covering Cambridge, Edexcel, AQ and Oxford specifications. Let us move. Accurate relative atomic masses. What we'll be understanding to understand why some relative atomic masses are not all numbers. If you check periodic chart and those, this will not be this whole numbers. So to define the terms relative isotopic mass and relative atomic masses, and to explain the concept of isotopes. To calculate the relative atomic masses from isotopic abundance. Now, relative atomic masses and isotopes. What is an isotope? So, atoms of the same element with the same number of protons but different number of neutrons. So, their atomic mass will be different, but atomic number will be same. Like, for example, here in case of hydrogen, protium is 1H1, which is having one proton and no neutron. Deuterium is having one proton and one neutron, and its atomic mass is 2, and tritium is having one proton and two neutrons, so atomic mass is 3. So this is relative isotopic mass. So these, keep in mind that isotopes are having same chemical properties, but their physical properties are slightly different. So when we discuss relative isotopic mass, we say that the mass of specific isotope of an element compared to 1/12 of the mass of the carbon 12 atom. So carbon 12 is taken as standard, and 12th portion of carbon 12 is taken as 1 unit, and we are comparing this with all the elements and other isotopes. So it is a specific value for each isotope and is very close to the mass number. So this is like carbon 12 will be 12.000 and up to 30. So chlorine will be 34.969. 37 will be, no need to memorize these. This is just for your conceptual clarity. So we are rounding closer to this will be 37, this will be 35, this will be taken as 12. And chlorine isotopes, if we discuss, chlorine is having two isotopes. One is chlorine 35 and 37. So 17 protons and 18 neutrons, 17 protons and 20 neutrons. So mass number is different, whereas their atomic number is same. The existence of isotopes is different in different proportions is reason why the relative atomic masses of most elements is not a whole number. So we are calculating the percentage abundance. So relative atomic masses, how we are checking? So weighted mean, we are checking for the weighted mean mass of an atom of an element compared to 1/12th of the mass of the carbon 12. Now it accounts for the mass of each isotope. It also accounts for the abundance, how common basically each isotope is of each isotope. So generally, if we are taking, for example, say 100 atoms of the same element, so how many will be of one specific isotope? So it is the value you see on the periodic table also, right? Then we can understand this concept from an analogy. Weighted test scores. Imagine two tests, like for example, one test is a final exam, which is scoring 90, and worth is 80% of the grade, and whereas homework is scores 100 and worth 20% of the grade. So weightage for homework is 20%, and this one is 80% weightage. So how we will calculate? We will multiply. Simple, if we just calculate uh, average of 90 and 100, we will get 95. This is simple average, but we don't need simple average, we need weighted average. So how we can calculate? Weighted average will be 90 will be multiplied by 80%, and 100 will be multiplied by 20%, and we will get 92. 92 will be weighted average. We are giving more weight to, or more importance to, the final exam as compared to the homework, and the relative atomic mass is calculated in the same way using isotopic masses and their relative abundance. Hopefully you understand this by the example, and now we can go through the formula for relative atomic masses, and this is the formula. And relative atomic mass is sum of the isotopic masses multiplied by a percentage abundance divided by 100. So we can go through this question, which is saying a sample of chlorine consists of 75 percent chlorine 35 and 25% of Cl35. Calculate the average mass of an atom of the chlorine. So we will be multiplying percentage abundance by its mass, and then we are getting these numbers. We'll add this one for 100 atoms, and one atom will be 35.5. So relative atomic mass is 35.5. Hopefully you understand this. This is the same thing which in periodic chart they are mentioning this one. So roughly 35.5. This matches with the value of the periodic table. Now, mass spectrometer, the accurate masses and abundances of isotopes are determined using the mass spectrometer, and it looks like this one. It's like a general diagram, simplified diagram, which we have shown over here, and this will be having some steps. First, key stages relevant to relative atomic mass. First one is ionization. So ionization is happening at this level. So say there is a sample vaporizer filament, and then sample is injected from this portion and sample molecule. So basically the functioning is not in your syllabus. Detail of spectrometer is not there in your syllabus. I'm just explaining for your understanding. So then this is the electron beam, and accelerated ions are going to this level, and then due to this magnetic field, they are having different deflections, and detector is here. So what are the key stages? First one is ionization. Atoms are bombarded by electrons to form positive ions. So 35 plus 1 and 37 plus 1, for example, if we are taking chlorine as an example. So then the second step will be accelerated. The ions and are accelerated by an electric field, and then deflection, which is ions are deflected by magnetic field. Lighter ions are deflected more, heavier ions will be deflecting lesser. Then the last stage will be detection, and the detection records the mass to charge ratio m over z and the abundance of each ion, and then we are taking the output, which is mass spectrum, and it looks like this one, which is like relative abundance in terms of percentage, and this is mass over charge ratio. And peaks we will be getting. Each peak represents a different isotope. Mass over charge value gives the relative isotopic mass, and the peak height area gives the relative abundance. This data is used directly in the relative atomic mass calculation. So hopefully you understood each and everything. Again, I just remind you that you will have to go through all these 8 videos, and those are there in the playlist, and this will be covering your whole topic. Thank you very much for watching. Take care. Bye.